Hi, I'm Kevin Horsfall, Assistant Director of Resource Management and Development for the Forest Preserve District of DuPage County. And today I'm a solar ambassador for the Illinois Solar Energy Association. And we're excited to share with you some of the components of our solar project here at our Blackwell Fleet Management facility, located in West Chicago, Illinois. The Blackwell Fleet Management building was constructed in 2018 and is home to the district's award-winning green fleet of alternative fuel vehicles. And it only made sense that the building should also be powered by renewable energy sources, such as solar panels, to support one of the best small green government fleets in the country. The Blackwell Fleet Management Facility solar energy system is the district's fourth solar array and largest constructed to date at 260.2 kilowatts, which will avoid over 230 metric tons of carbon emissions to the atmosphere. We started the process of getting panels installed on the facility through a competitive bid process in April of 2022. While it often takes 3 to 4 months to complete a project from start to finish, our project took over a year due to supply chain issues in coordination with ComEd for replacing the facility's main transformer. The work was finally completed in May of 2023. The Blackwell Fleet Management Solar Array has 532 495 watt panels, which will supply approximately 100 to 110% of the power required to operate the facility, including several level 2 EV charging stations located externally. As we look to expand our EV fleet, we anticipate adding more stations in the future and will reevaluate adding additional panels and inverters in the future. While the district looks at solar development primarily through a return on environment lens first, and then return on investment second, we have been very successful in accomplishing both, with many of our solar installations on target to meet payback within 8 to 14 years, and ultimately saving the district several hundreds of thousands of dollars over the life of the solar energy systems. And this project was no different. One piece of advice for those wanting to go solar is to make sure your facility or home is solar ready first. And this involves having an electrical engineer or a structural engineer review your roof or review your electrical requirements to make sure that you can install a solar energy system. Here you can see our solar panels. They're installed on the east-west side of the facility. There are 18 strings of approximately 20-30 panels per string. We have a combiner panel disconnects on the roof, as well as disconnects at the inverters for ease of maintenance and troubleshooting. Due to the complexity of our solar energy systems, our equipment is located inside and outside of the facility. The meter for the facility is located externally outside our electric room. It tells us how much energy we are putting on the grid from excess solar production and how much we are taking off the grid when we're not producing enough for our own needs. Next to the meter is the emergency disconnect that allows first responders to shut down the solar array safely and quickly in the event of a fire. Here inside the electric room, we have the main panel board that the solar energy system connects to. One of the challenges with our facility was taking into account a transfer switch and backup generator after the meter. It was important not to connect the array on the line side to prevent damaging a generator if it ever was needed. Our inverters are located in our mezzanine and are responsible for converting our DC energy generated by the solar panels and converting into AC energy that can be used by the facility. Unfortunately, due to material availability, we had to work with our design engineer and contractor to modify our design based upon the equipment and panels available. The original design required 450 watt panels and 3 inverters to produce approximately 330,000 kilowatt hours of energy to meet our system demand. In the end, we were able to design a system that would generate approximately 324,000 kilowatt hours annually using 495 watt panels and 2 inverters. The total cost of this project, including all design, permit, and construction fees, was about $585,000, which equals about $2.25 per watt. And that's the end of our solar tour. I hope it answered any questions you have about what a solar project may look like. If you have any more questions, the Illinois Solar Education website has a lot of resources. Visit them at www.illinoissolar.org.